Last chapter we studied independence, when learning one event tells you nothing about another. Now the whole subject takes a turn. So far, outcomes have been abstract things, a face of a die, a point in a sample space. In this chapter we attach a number to every outcome, and that single move unlocks sums, averages, and limits. We'll define a random variable as a function, focus on the discrete case, and describe it completely with one object, its probability mass function. Then we'll put a PMF to work on a small example. Here is a sample space omega with a handful of outcomes. A random variable is nothing mysterious. It is simply a function that sends each outcome to a point on the real line. Roll a die and the natural random variable is the number of dots on the top face, outcome to number. Notice that different outcomes are allowed to land on the same number. The map need not be one-to-one. Formally, we write x maps omega to the real numbers. That real number attached to an outcome is called the value of the random variable. The random variables we study first are the discrete ones. A random variable is discrete when its range, the set of values it can take, is finite or countable. A die gives a finite range, 1 through 6, but discrete does not mean finite. Toss a coin repeatedly until the first head and record how many tosses it took. That count can be 1, 2, 3, and on forever, a countably infinite range. Both are discrete. What they share is that we can list their values one by one. To describe a discrete random variable completely, we only need to say how much probability sits on each value. That is the probability mass function. The mass of x, written little p sub x of x, is just the probability that x equals x. And x equals x is really an event back in the sample space, the set of all outcomes that x maps to x. That set is the preimage of x, and its probability is the mass. So the PMF simply pushes the probability law forward from the sample space onto the number line. As x ranges over all the values, these preimages are disjoint and cover the whole sample space. They partition it, so the masses must add up to exactly 1. And once we have the PMF, the probability that x lands anywhere in a set S is just the sum of the masses over S. The PMF is the whole story. Let's make it concrete. An urn holds 3 balls numbered 1, 2, and 3. We draw 2 of them without replacement, and we record the order, so there are 6 equally likely outcomes. Let the random variable x be the sum of the 2 numbers drawn. Work out the sums. They can only be 3, 4, or 5, and each occurs for exactly 2 of the 6 outcomes. So the PMF is 1/3 on 3, 1/3 on 4, 1/3 on 5. Now suppose we want the probability that the sum is odd. The odd values are 3 and 5, so we just add their masses. 1/3 plus 1/3 is 2/3. That is the pattern for the whole chapter. Build the PMF, then sum the mass over the values you care about. A discrete random variable is completely described by its probability mass function. Next, we meet named distributions.